let's look at another molecule that has resonance, and you have to use the formal charge to make a better structure. So let's look at the phosphate ion. So phosphorus is in group 5, and there are 24 electrons from oxygen plus another 3 electrons. So we have a total we have 32 valence electrons. So we'll put phosphorus as our central atom. We'll draw the 4 oxygens around phosphorus. And then we've used 1, 2, 3, 4, 5, 6, 7, 8 of those electrons, so we have 24 that we need to assign. So I'm going to start with the terminal atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, we have all of the valence electrons assigned, and the most correct way to write these, right, is in the with the brackets to indicate it's an ion, but we should calculate the formal charge for all of these different atoms. So for example, let's calculate the formal charge for oxygen. So oxygen's in group 6, so it has 6 valence electrons. And then it has been assigned 1, 2, 3, 4, 5, 6, 7 electrons, so that's a -1. So each one of these oxygens, since they all have the same number of bonding and non-bonding electrons, has a -1 formal charge. Let's calculate the formal charge on phosphorus. So phosphorus is in group 5, so it has 5 valence electrons, and let's count the electrons that are assigned to it. 1, 2, 3, 4. So 5 minus 4 is +1. So phosphorus has a positive charge on it. Now we could minimize the total number of charges by taking one pair of these electrons and allowing it to bond with phosphorus. So let's consider what that would look like. Okay, so I have all of my valence electrons. And if you check the formal charges on these different oxygens, you would see that these singly bonded ones have a negative charge, and that the double bonded oxygen has a formal charge of 0, and so does the phosphorus. And you notice that phosphorus has 5 different bonds, so it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, so this violates the octet rule. but this is a better structure because the formal charge has been minimized. In addition, there are resonance structures for phosphate. And what you could do is you could push in a pair of electrons to share a double bond with phosphorus from this oxygen on the upper right, and then if that happens, then these electrons that are in the double-double bond, or the double bond with oxygen and phosphorus, one pair of those electrons can push back up to oxygen. Okay, and then the same thing can happen with these next pair of electrons. I'm going to go to the next screen because I've run out of room. But the oxygen that was at the bottom had the double bond. And finally, the last resonance structure will be if these electrons push in to form a double bond with phosphorus, and then one of the pairs of electrons from the double bond gets pushed back up to the oxygen. So in total, there were 4 different resonance structures for this molecule that satisfied the optimal formal charge.